Welcome to our last lesson in this unit. We are going to cover graphing quadratic inequalities in two variables today. It's very similar to graphing linear inequalities, and we're going to follow the same steps. Before we begin, just a reminder that if we have strictly greater than or strictly smaller than, you're going to have a dotted line. Or if you have greater or equal to or smaller than equal to, you're going to have a solid line. So the same thing applies. Now we are going to graph quadratics here, and you do need to remember our quadratics unit to do this. We have the vertex form, so right off of what's given to me, I can read off the vertex. We have a vertex at 3, 1. We could also find the y-intercept and graph that as well. We could also find x-intercepts if we wanted to, or just use the table of values, but it's really up to you. I'm just going to find another point by finding the y-intercept. And when I'm finding the y-intercept, I'm just going to change our equation so that it equals to our parabola. And then when we're finding our y-intercept, we set x equal to 0. So then our y-intercept is going to be 9 times negative 2, which is negative 18, plus 1 from that is negative 17, is our y-intercept. I'm going to go ahead and graph our parabola using those 2 points. I'm going to go down by 2's here. I'm going to graph 3, 1, which is this point here, and also graph 0, negative 17, which is about here. And then I'm going to connect those 2 points, extend a bit for the arrow, and we know that our parabola is symmetrical on each side of that axis of symmetry, which is located at x equals 3. So I know that there's also going to be a point then at 6, negative 17. Okay, so that's our parabola. Now take a note that we actually had a strictly smaller than sign, so I do need to change this up a bit and put in my dotted points instead. Okay, and then that would be our graph. Just like the inequality graph, we do need to find a test point so we can shade in the correct region. And we're going to pick a point that is on the outside of our line, or the inside of our line, but it can't be on our line. So I'm just going to pick 0, 0, because that is on the outside of the parabola. And I'm going to put it into our inequality to see if it's true or not. So if it's true, we're going to shade that region. If it's not true, we're not going to shade in the region where 0, 0 is. So I'm going to plug in 0, 0 in for my x and y. And then I'm going to go ahead and simplify this. Now it's saying 0 is smaller than negative 17. This is not true. So that means we're not going to shade in the side of 0, 0. So we're going to shade in the side that doesn't have the point 0, 0, which should be on the inside of that parabola then, which is located in here. And that is our graph. Let's try another one. This time, the inequality that's given to us is in standard form. So we can complete the square, so we can get this into vertex form, so it's easier for us to graph. I'm going to change this to an equal sign just because I am just changing it into vertex form. Okay, so I'm just going to have the first two terms. I'm going to take the second term, that's -4, divide it by 2, and then square it, which is 4. I'm also going to subtract 4. And I left the -5 alone. Then I'm going to factor this portion here, which is going to be x minus 2 all squared. I'm going to simplify this -4 minus 5, which is -9. So that means we have a vertex at 2, -9. Now the next thing we want to do is find another point. We could just find the y-intercept. And then when we do this, we will plug in x equals 0. And we're going to get back -5. So I'm going to go ahead and graph those 2 points that we know. Just going to go down by 1. Okay, my first point is at 2, -9. My other point is at 0, -5. And then we also know this is symmetrical. Our axis of symmetry is at x equals 2, which means I also have a point at 4, -5. In this case, I'm going to connect my point with a solid line because it is greater or equal to, and I'm going to keep extending this a bit. It's just going to be approximate from here, so that's easier for me to shade in the region. Now the second thing I'm going to do is find the test point. And we can pick 0, 0 again, because that's not on the line. We're going to plug it into the inequality to see if it's true with the test point of 0, 0. Is 0 greater or equal to -5? Yes. So that means we're going to shade in the area that has the point 0, 0. And that would be the inside part of the parabola, like this. And that is our graph. Now we're going to apply this to word problems. So Sam and Jared want to learn how to rock climb. They have enrolled in one of the summer camps in southern BC. In the brochure, they came across an interesting fact about the rope that is used for rappelling down a cliff. It states the rope can safely support a mass m in pounds multiplied by the inequality m is smaller or equal to 1,450 d squared, where d is the diameter of the rope in inches. And they want to graph this inequality and examine how the mass of that rope supports is related to the diameter of the rope. So right off the bat, this is our inequality, and if you take a note of our a value, which is 1,450, this is going to make our quadratic very narrow. So when we're going to graph this out, we're just going to do this approximately, just because we know it's going to be very narrow. We have a vertex at 0, 0. So I'm going to go ahead and draw a narrow graph, and then maybe at this point here, I can say that it's going to be 1450. That's going to be 1. And that would be our first point. Because D, which is down here, if D is 1, 1 squared times 1,450 is 1,450. And instead of it being called our y-axis, this is our m for mass. Okay, now we want to find our test point to see what area we're going to shade. And we cannot pick 0, 0 in this case because 0, 0 is a point on the graph. So we are going to pick 0, 1. So that means this is my D and this is my M. So M is smaller or equal to 1450 D squared. If I put in 0 for D and 1 for M, we're going to get 1 is smaller or equal to 0, and this is not true. Which means I would shade the outer portion of our parabola. Now, I'm not going to shade the other side because that means that D would be negative. And we can't have D be a negative number because that's our diameter. Diameter is not negative. So I'm only shading that one side then. So how we're going to interpret this graph, if we take a look at the region that we did not shade, we had a really small diameter in the area that we couldn't shade in, which would be in here. And if we had a small diameter, this means that we cannot support large mass. And that is our relationship. Here's another example. Two numbers are related in this way. 4 times the square of one number is less than 2 times the sum of the other number and 3. And we want to graph that. So we have to write this as an inequality. We're going to take it step by step at a time, reading one piece of our sentence at a time. So 4 times the square of one number. We're going to call one of these numbers x then. So one number is x, and then we're going to have another number, so the second number can be called y. So 4 times the square of one number, so we're going to square that x, is less than, so it's smaller than, 2 times the sum means add, of the other number and 3. So sum of y and 3. Remember to consider your order of operations. We're going to do y plus 3 before multiplying it by 2. 2 times the sum. So 2 times the sum here. Okay, so that's our inequality. We're going to simplify this. Multiply that 2 to each term, and then subtract 6 on both sides, and then we can divide both sides by 2. All right, so this is what we are going to graph. We have a parabola with a vertex at 0, -3. And we are not going to find a y-intercept because we are already given the y-intercept because our vertex is right on the y-axis. So what we can do instead is find another set of points. and put it into the equation y equals 2x squared minus 3 to find the other y value. So let's just go on either side of our vertex. You can find maybe x equals -1 and x equals 1. I'm going to plug it into that equation to find the y values. That's 2 times -1 squared minus 3. That's -1. And I'll do the same for x equals 1. Okay, so we have 3 points. We're going to go ahead and graph those 3 points. So our first point is at 0, -3. Then we have a point at -1, -1, and +1, -1. I'm going to connect these points using a dotted line because you have a strictly smaller than, and then I'll extend it to the best of my ability. Here we go. Now the next part, step 2, this was step 1. So we are going to find our test point to see which side we're going to shade. And we can use 0, 0, because that is not a part of our line. It's not on our line at all. So I'm going to use this 2x squared minus 3 is smaller than y. I'm going to put 0 in for x and y. Then we're going to get -3 is smaller than 0. This is true, which means that we're going to shade in the area that has the point 0, 0, which is on the inside of our quadratic. And that's our graph. Then for part B, we want to pick 3 pairs of integer values for those 2 numbers. So if I pick anything in that shaded region, we're going to get the x value and then the y value, which is number 1 and our second number. So we can pick anything in the shaded region. So that means we can pick 0, 0. We can pick 0, 1, that fits in our shaded region. You could also pick -1, 5 or something like that. That's also in our shaded region. And we're supposed to pick integer values, so make sure whatever you pick is not a decimal number or a fraction. So that means if I put in 0 as my first number and 0 as also my second number, this inequality we found here is going to be satisfied. And if I put in -1 as my first number and 5 as my second number, again, we put that into our inequality. That means this inequality is satisfied, and it follows through that this would be true with our set of x and y values.